Putting you, baby, I'm putting you, baby, I'm putting you, baby, that back. I'm putting you, baby, right out, right out, right out of my mind. Right out, right out, right out, right out, right out. So tired of running after you, girl, and being one of one-hour steps, and being one of one-hour steps, and being one and one and one and one and one and one and one-hour steps behind.
Hey Jude, don't make it bad. Take a sad song and make it better. Remember to let her into your heart. Then you can start to make it better. Hey Jude, don't be afraid.
loving you more. I am 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 loving you more. In the
I'll try my best. How much do I invest? Like cardiac arrest. High voltage in her lips. I'll try my best. How much do I invest? Like cardiac arrest. High voltage when we kiss. Like cardiac arrest. High voltage in her lips. Like cardiac arrest. High voltage when we kiss. I'll try my best. How much do I invest? Like cardiac arrest. High voltage in her lips.
Hey, I hear the voice of the preacher from the back room, calling my name and I follow just to find you. I trace the faith through a broken down television and put on the weather. And I've trained myself to give up on the past, cause I've frozen time between hearses and caskets. Lost control when I panicked at the acid test. I wanna get better. While my friends were getting high and chasing girls down parkway lines, I was losing my mind because the love that I gave wasted on a nice face. In a blaze of fear, I put a helmet on a helmet, counting seconds through the night and got carried away. So now I'm standing on the overpass, screaming at the cars, hey, I wanna get better. Didn't know I was lonely till I saw your face. I wanna get better, better, better. I wanna get better. Didn't know I was broken till I wanted to change. I wanna get better. To my room and there's girls on the ceiling. Cut out the pictures and I chased that feeling of an 18-year-old who didn't know what loss was. Now I'm a stranger. And I miss the days of a life still permanent. More in the years before I got carried away. So now I'm staring at the interstate, screaming at myself, hey, I wanna get better. Didn't know I was lonely till I saw your face. I wanna get better, better, better. Didn't know I was broken till I wanted to change. I wanna get better, cause I'm sleeping in the back of a taxi. I'm screaming from the bedroom window, even if it's gonna kill me. Woke up this morning early before my family, from this dream where she was trying to show me how a life can move from the darkness. She said to get better, so I put a bullet where I should have put a helmet, and I crashed my car cause I wanna get carried away. That's why I'm standing on the overpass screaming at myself, hey, I wanna get better. Didn't know I was lonely till I saw your face. I wanna get better, better, better. Didn't know I was broken till I wanted to change. I wanna get better, better, better.
Testing, testing. Does that sound clear to everyone? Yeah? Okay. Just so y'all know, there's like 3 minutes until we get started. Okay. Hello, everybody. Cheering section, come on. No. Let me move this away just a little bit. There we go. All right. So, I'm going to do just a brief couple-minute introduction here, and then we can just start diving in. We have a lot to go through today, so let's just get going. First and foremost, my company that I'm with is called Move It. We're a software development consultancy. As you can read from the slide, we're about 100 people spread across the Americas. We work with clients large and small, ranging from Disney and Hulu to random startups that you've never heard of. We work across a bunch of different tech stacks, Node, Ruby, Java, a bunch of different ones, mobile development as well. And we're always hiring. So if you're a senior developer or a mid-level dev, and by that I mean like you've been professionally developing for 4 years plus, hit us up because we're definitely interested in talking. So just briefly, who am I? My name's Jared Selko. I'm a software developer with Move It, if that wasn't obvious. I typically do about 75% of my time writing code and the other 25% doing things like this, setting up events, meeting with clients, doing general business development. I'm really passionate about writing software, and I love learning about new technologies, so this seemed like a good opportunity to put that to use and learn something fun in the process while teaching it to you guys. So let's get going. First, I'll talk about what we're going to be creating today. So what we're going to be making is 4 separate applications. It's going to be a user service that talks to a database to handle user authentication, as well as storing those users. It's also going to be a music service, which is going to basically talk to a database to handle storing songs that those users favorite. And then it's also going to be an API gateway, which is going to basically sit in front of our services, and it's what our interface is going to talk to. So the gateway is going to be responsible for handling all requests from the UI, and then putting out the proper requests to our respective services, combining all the data, and sending it back. We're also going to obviously have a UI, because otherwise what would we be doing here? The gateway, just a little bit more detail about why we're doing this. If any of you guys have tried to go through a GraphQL tutorial, they probably haven't talked about federation or microservice architectures. It's typically been like a contrived example that's just one big service that handles all of the things. And that's all fine and well, but in production environments, what you'll find a lot of times is that you have a company that has a bunch of these microservices sitting behind a VPN so that not every service has to worry about authentication. Each of these services can just assume that if someone's talking to them, the authentication's already been established and it's a safe channel of communication. So typically what you'll have, or frequently what you'll have, is a bunch of these microservices behind a VPN and then a gateway that's exposed to the outside world. And that gateway has special permission to talk with those services through the VPN. So because this is such a standard setup, and I found that there was kind of a dearth of tutorials about this, I decided to roll that into what we're doing today because it's very practically useful. To do that, we're going to do something called schema federation, which is a bit complex, but I think is going to be worth the time. So just to give you guys a little context as well, the interface is going to drive how we create everything that we're about to create. One of the tenets when working with GraphQL is that you want to have a client-first mindset because basically the schema, which is basically you can think of it as the API documentation that also serves as the source of truth for how the API works. That API is going to be what your client is talking to. So you want to design that API in such a way that the client will find useful. So with that in mind, we're going to be designing 6 separate mini pages for our application. One is going to be a home page that's going to list the 20 most recently favorited songs. One's going to be a song page that shows the song information and lyrics, and you reach it by clicking the top of any of the songs listed on the home page. There's also a user page, which lists that user's favorite songs, and it's reached by clicking the bottom portion of a song. There's also a sign-up page, because that's how people need to be able to get onto the website. There's a login page after you've actually signed up. And there's also a profile page, which once you've logged in, you're able to then see your favorite songs, edit those songs, and upload new ones. So the important links here are the repository, the presentation, and the supplemental notes, which are basically going to mirror what we cover here, plus significantly more. If you want to follow along with your computer, you are very welcome to, and I recommend opening the presentation. You can do it with photographing this QR code. It's also the link down below it. If you want to just listen, that's also fine. We're going to move at a relatively steady clip, so you're probably not going to write a ton of code. But as you'll see, we're going to step through this application from none of the primary files in it being written to all of them being written as we step through a series of git commits. And I've also listed in the documentation that is in this presentation, I've listed each of those commits and what you're doing in each one. So you can then follow along later if you'd like. Okay, so if you are following along, the first thing that you're going to want to do is clone the repository. By show of hands, just so I know, is anyone actually doing that, or should I just assume that no one's actually you got a few people? Okay, cool. So the first thing you're going to want to do is clone the repository. So git clone, and then my user is JOrionS, and the specific file is GraphQL React hooks workshop.git. So clone the repo. Then run this command to install everything. And if you have the presentation open, I recommend just copying that text and pasting it into your terminal, because we're basically going to be running an installation across like 4 separate mini repositories within our large primary repository. So once you have that going and all of the installation commands basically running in the background, once that completes, the last thing is going to be the standard stuff, which is copy your .env.sample within each folder and rename it, make that copy and call it .env. For anyone not familiar with what that is, it's an environment variable file so that when our application runs, it has access to these files in their memory. The last thing that we're going to do is run these 2 commands in these 2 folders. So in the user service /start folder, you're going to say npm run dbcreate, and then in the music service /start folder, you're going to run the same command. And what both of those are going to do is populate a SQLite, file at the top level of the repository just to get everything going. So I'll hold here for like 5 seconds. Okay, moving on. The next thing that you can do, and I'm not going to have you all sit through the sign-up process right now, but I highly recommend it, because if you use the supplemental docs, it's going to assume that you've done this. And this is just the step-by-step of what you do. You sign up with GitHub, authorize it, give an email, create your organization, and then select the free plan. And what it's going to do is it's going to provide a way for you to view and manage your schema through a schema management system that they provide that also provides a lot of analysis and data tracking, which, as you'll see in a few minutes, is a really important part of GraphQL. You can't really just spin up a GraphQL API in production and then hope things go well, because it's a really chatty infrastructure. So you need to have these analysis tools to make sure that things go smoothly at scale. The next thing here, again, optional, is downloading these tools. I highly recommend it because I think that it helps with all the things. If you use Atom or VS Code, these are the 2 links for the respective packages that will then provide linting support and syntax highlighting support for GraphQL syntax. And the dev tools for Chrome are also handy if you use another browser, sorry. Okay, so that's the preliminary setup. So first, let's talk about what GraphQL is. So GraphQL is a query language and a API. So as I had mentioned a moment ago, it is basically a way for you to have a single source of truth that is self-documenting for how your clients are going to access data in your services. And this specific quote is a query language for APIs and a runtime for fulfilling those queries with your existing data. It provides a complete and understandable description of the data in your API. So this centralized flexible API is going to represent a new layer in our tech stack, and we're going to call that the data graph. That may be a phrase that you guys have heard of in the past. This is essentially, conceptually, what you can think of as like where the data graph is going to sit. So in the past, you would have a bunch of microservices, and you'd have a bunch of different devices talking to a bunch of different microservices. And in a lot of scenarios like I just described, you might have something sitting in the middle called the API gateway, right, that's going to receive these requests and then talk to the services behind a VPN. In our application with GraphQL, what we're going to have is this data graph, which can use a gateway if we want, but it can also just be this sort of centralized, you can think of it as a centralized API that everything is going to flow through and then out to your respective services, and it's going to coordinate each of those communications. So what is a data graph? So in our app, we're going to have users and songs, right? So what we can think of a user and a song as are nodes, it's called. So in the words of Neo4j, which is a graph database, a data graph is a specification for querying a slice of the application graph, retrieving a tree of data. That's a kind of confusing phrase, right? What does that actually mean? What that means is that it's a layer of abstraction that permits you to think of your data in terms of their relationships. And you'll see in just a minute what I actually mean by that. So this is conceptually what you can think of as a data graph. So this is just a picture I took off the internet, so we don't have users and posts, we have users and songs, right? But the concept persists. You have individual items, entities, like data constructs, nodes, and they have relationships to each other. So in a traditional SQL database or relational database in general, you would have a user table and a song table, and songs would have user IDs, right? So you'd have this foreign key relationship between songs and users, and you would say, give me all of the songs with a user ID of 1. Well, that's fine, but what a data graph permits us to do, and I'll move forward. Oh, actually, no, let's stay here for a minute. What a data graph permits us to do is actually query the relationships themselves. So instead of saying, give me all of the give me all the songs with a user ID of 1, you'd say, I'm already looking at the user ID of 1, give me all of the songs that they have a favorite relationship to. So relationships actually become their own concrete piece of data. It's no longer just the two separate concepts of a user and a song, but now a third set of data, the relationship between them, and you can query directly on these relationships. So that's what conceptually a data graph is. So the important thing to remember with a data graph is that we aren't specifically going to be actually using this non-relational structure under the hood, right? We're going to be using SQLite. So we're still going to have a relational database. But what GraphQL lets us do is provide a layer of abstraction on top of it that lets us act as though we have these concrete relationships. So, and we'll see in just a minute what that actually means. But let's talk for a moment about why we would want to do this in the first place. The first reason that you'd want to do this is because it permits you to request only exactly the data that you need, and you'll see how in just a moment. This is obviously good for situations where your data is limited, like in mobile scenarios. You can also flexibly serve multiple consumers with one consistent API. As I was saying before, your schema, this self-documenting list of all the things that your API is able to do, is your one source of truth for everything. It also potentially enables faster development because you can start developing new features in your UI without actually having to change your backend very much. And again, we'll see how all of that happens in just a few minutes. And then the last thing, especially if you use these Apollo tools that I had mentioned, you get really good data analytics because you start being able to see what data was queried for on a per field basis. So if you have 3 different pieces of your app, and one piece is asking for a song and the song's artist name, and another piece is asking for the song and its created date, and another is asking for the created date and the ID or something like that, then you could use this analytic software to see, oh, there's multiple places where specifically the name is being requested. And now that I know that the name is being requested in multiple places and it's a hot spot in my code, I can start to optimize for that accordingly. Okay, so what is a schema? I've used that word a few times now. So it's a document that describes the functionality available to clients. And this is what a schema looks like. So what you have are types, right? And you define a type with a name, so a song and a user. And then you say what fields those types possess. So an ID would be of type ID, and we'll talk about what that means in a second. An artist's name would be a string. The name of the song would also be a string. The lyrics, a string. The reason that you're favoriting it, which is a thing we support, is going to be a type of reason. And the user that that song belongs to is a user. And then below that, you have a user type with an ID, an email, and a favorites, which is an array of songs. And so you can already start to see this circular relationship between these two types. And I haven't even actually written anything in my database yet, but already there's this conceptual connection, this conceptual relationship that's been defined that you're able to then query off of without having to say, the traditional relational database stuff that we were just talking about. And just so you guys know, these exclamation points represent required, which is to say that if my API is providing back a song to the front end, it doesn't have to, the front end doesn't always have to ask for a name. It doesn't always have to ask for an artist, but the underlying structure needs to be able to at least send it on as an option if the client wants to consume it. So that's what exclamation points mean, is required. So if we're returning a song and that song doesn't have an artist or an ID, then we're going to actually see errors. Okay. So talking about types briefly, there's several types that are the base types. These are called the scalar types. One is an int, which is just a normal integer. Float, which I'm sure we're all familiar with as well, right? Decimal number. Strings, is a string. Booleans, and IDs. So just so you know, if your database represents an ID as a number, it's still going to come out of this as a string. It's serialized as a string, which is an important point to note, because if you start trying to do data comparisons, like saying, is my ID equal to this or that, you're going to need to remember that it's always going to be a string whenever it's being consumed by the client. You can also define your own types, but that is far beyond the scope of this presentation. Okay, so the next thing that we're going to talk about is object types. We already briefly looked at this, right? So it's literally defining an object and giving it a type with a name. And then you have these fields, which, as we just discussed, are composed of these scalar types. Well, these four are scalar types. The reason and the user are more complex types, which we will talk about in a moment. So the reason type that we just mentioned is an enum type. And what that means is that it is a scalar value that is restricted to a specific set of values. So what that means is that anytime someone starts requesting a song or trying to say that they have a new favorite song, that the reason that they give is going to have to be one of these three values, and it's going to literally be an all caps string lyrics, an all caps string sound. So the next type that we have is a query type. So we've already discussed what types of data can be served back, as well as what types of data can be requested. But we haven't talked about how that data gets requested in the first place. So there is a specific type called a query type. So where before we were saying type user or type song, whenever you say type query, query is a special word in GraphQL. So it immediately knows, okay, whatever I'm defining in here is going to be a query in some way that I can receive, and then I'm going to serve up information for. So we can have two different queries, one called getUsers, one called getSongs, that returns an array of users and an array of songs. And again, this exclamation point means that it must at least return an empty array. If I had user exclamation point and then a closed bracket and another exclamation point, it would mean that it would have to always be at least an array of one user, right? So exclamation point always means required. So this is what we would have on the schema. Then if we had our client making a request, this is literally what client requests look like. They have this nested sort of JSON-y structure. This is the tree structure that was just being described. And so you'd say, I want to make a query, and so it's going to connect these two concepts of a query automatically. And you're going to say, the query that I would like to make is getUsers, and so it's going to see that within query we have getUsers. And then you're asking for the name of each user. And so it's going to know, okay, this is an array, and I'm going to have an array of objects that are users, and I want the name of each one. And this is what the response would look like coming out of GraphQL. So you'd have data, which is like the base key that you always have, and then an object that contains the keys that are the names of your queries. And then within that, the array, which is the array that getUsers and getSongs returns, and then it's an array of objects that would have name keys. Making sense so far? Cool. So, mutation type. This is conceptually very similar to a query. The difference is that where a query is just simply asking for data, a mutation type is sending new data to the database or a change to existing data. So where a query is a type query, mutation is the type here, right? And just like before, you define a type of, or excuse me, a name for the mutation, and then a thing that it's going to respond with. So in this case, we're also, if you've noticed, we're passing arguments to the query, or excuse me, to the mutation. So this is a syntax which represents that any values that this mutation is receiving are going to be an artist, a name, and a reason, and they're going to be a string, and a reason. And this exclamation point, again, means that if you were to try to make this mutation called add favorite and you didn't have a reason, GraphQL would automatically throw up an error saying you need to have a reason. And if it's a reason that doesn't match one of the listed reasons of lyrics, sound, or everything, it's again going to throw an error saying, hey, this isn't one of the listed types that we agreed upon. So you would define your mutation this way. And then this is what the query would look like coming from the client. So mutation, add favorite, and this name is anything that you want it to be. We're simply calling it this just for the sake of consistency and descriptiveness. The name that matters is the one inside, because that's what's tying to the add favorite here. So we're passing an artist, a name, and a reason. So the artist, the Beatles, the name, Hey Jude, and the reason, everything, because that song is awesome. And then you're asking in response for this object. It's going to be an object that contains a success Boolean, a message if something's gone wrong, and a song. And again, this is what it would result in from the server. Data, add favorite, success, message, song, ID, artist name, reason. Fairly self-explanatory once you start looking at it for a few minutes. So what you may have noticed is that we were hard coding those values just a moment ago of the Beatles, Hey Jude, and everything. Obviously, in production, that doesn't really make a lot of sense. You'd like these things to theoretically be flexible and receive user inputs. So this is where variables come in. This is a way to signify the data that will be provided to a query or a mutation. So the variables, as you can see, are here. So the syntax is really similar to what we just had, right? Before, we had artist, colon, the Beatles, name, colon, Hey Jude, reason, colon, everything. Now what we're saying is reason, name, and artist are all variables, and those variables are going to be passed in by this upper level function that we've defined, that we've called add favorite, but again, don't need to call add favorite. We could call it make a change and just say that, okay, make a change is going to receive an artist, a name, and a reason. And again, these names also arbitrary. I picked artist, name, and reason for consistency with the values they represent, but I could call this A, B, and C, and it wouldn't matter. And as you can see, the declaration syntax is the $sign followed by the type, and then you can also set a default value if you'd like this. So the last thing that we're going to talk about very briefly is a thing called directives. It's a way to dynamically change the structure of a query or a mutation. So they can be attached to fields or fragments. We haven't talked about fragments. It's in the documentation. There just isn't time to cover it today. The usage syntax is always you're going to have at as the beginning of the directive, then the directive name, and then any arguments that it receives. So the two that GraphQL includes out of the box are include and skip. And the syntax here is simply that you are saying, I want to include whatever field I'm attaching to if this thing is true. So we've got this query for a user, and we're passing in a user ID and a Boolean of whether we want to see those users' favorite songs. So if that Boolean is true, we will include the favorites array, and if it's false, we will not. The last thing that we're going to talk about briefly is schema descriptions. And this is simply a nice quality of life thing that you're able to do, which is add either single quote for a single line or triple quotes for block text like you see here. And it's basically a way for you to notate stuff inside of your schema. And that notation can be, one, in Markdown, which is convenient, and two, it can then be consumed by tools that are meant to integrate with GraphQL. So if you have an error, or if you rather receive a response and that response includes message, you can hover your mouse over the message field and it will tell you whatever note you've put for what the message is supposed to represent. So you can basically indicate to users how your the purpose of the different fields in your schema. Okay, so that was a lot of stuff, but we're about to cover a whole lot more, so buckle up. So what we've talked about so far is this concept of the schema, right, which is how you define what is permissible to be asked for and how those changes, or what types of changes and additions can be made to our data. But what we haven't talked about is how that actually happens, like what is the connection between our database and this schema. And that's where resolvers come in. They're called resolvers because they resolve the individual fields of our data. So they either are going to return the data outright, or they're going to return a promise that will eventually become the data. And under the hood, each GraphQL implementation knows that if it's receiving a promise or equivalent in whatever language, it's going to sit there and wait for the response before it then moves on. The resolver names that we're going to create need to match the types and the keys in our schema. That's the critical point here. That is how GraphQL knows to connect logic with the schema that you've just outlined. And you'll see what I mean in just a moment. So the last thing I'm going to talk about, or one of the last things I'm going to talk about here, is default resolvers. And all this means is that you don't necessarily need to write a resolver for all of your code to work. And you'll see what this means in just a few minutes. But what it basically means is that you are able to have a given function, a resolver, return an object. Let's say it's a user resolver. If that user resolver returns an email and a name and an array of favorites, then you don't have to have a separate resolver function to figure out the favorites list because it already received one higher up from the user parent. And you'll see here that this is really what I'm talking about. So this is what a resolver object looks like, right? So this is just an object that we export that we feed to the Apollo library, which is a GraphQL library, and we also feed it our schema. So it's looking at our schema, it's looking at this object, and it's combining it all together to figure out what connects where. So like we had before, this type query, right? And inside of it, we have a user query that receives an ID and sends back a user response. We also have a user response, which is going to be that success message, or the success Boolean, a message if something's gone wrong, and the user. And then a user has an ID, an email, and their favorite songs. So if we look at what the resolver looks like for this, we have this special query key, and inside of it, we have each of the queries that we've defined, right? So user here, user here. And you'll see in a minute what all of this is, but just suffice it to say, this ID is coming from here, right? So this is the arguments that you're passing into the query. So you're able to then say, okay, someone asked for a user, so what I'm going to do is I'm going to use my user API to find a user by ID, and then I'm either going to return false if there's a user error from that fetch, or I'm going to return success true along with the user. So now that we have this user that's been returned, we could just stop there, and GraphQL could call it quits and say, sweet, I've got my user, I'm done. But what we've done here is we've defined a user resolver, which corresponds to the user key here. So because we've returned a user, and we've defined a user response as containing a user that's of type user, this is where the magic of GraphQL comes in. It sees this identical named key in the object that you've returned, and it knows that that name corresponds to a type that you've defined in your schema. So it now knows, okay, this object that's getting returned that has a key of user, that user key is going to need to have an ID, and it's going to need to have a string email, and it's going to need to have an array of favorite songs. So it then is going to say, did I receive all of those things from what just happened? If I did, and nothing else is defined here, then I can just return that back. But if something's been defined that's specific to the user, then that means that the top level thing that I just did isn't the end all be all. Maybe I need to do something else. So what it does is it then looks to that type if it exists, and it then starts returning the fields that correspond to that type. So what you're saying here then is I'm going to return a user from here, and that user then is going to have an email, which is going to just be a hard-coded string that overrides the default email, where the default email would have been whatever was retrieved from the parent up here. And then you're also saying that the favorites key, which could have just been defined here and left alone, I'm also going to override whatever was done. And I'm going to say that I want to find all the songs from that user by the user ID. Okay. So the three arguments that we're going to be talking about and concerned with for resolvers are these first three: the parent, the arguments, and the context. So the info is a fourth one that's advanced and we're not even going to talk about. So the parent is the thing that was generated by the next level up resolver. In the case of a query, there's nothing above it, right? So that's why we've done this underscore. There's nothing above this, there's no parent above this because this is the first query getting hit. The second argument is an object containing all of the arguments. So in this case, an object containing ID. And the last thing is a thing called data sources, which we'll get into in a bit, but it's something that you provide as you create your Apollo application. And it's basically an API that you can use to query any of your data that you've defined. And then the last thing that we have is down here, you'll see in this favorites object, we now actually do have a value to work with for the parent, right? The parent that was received from here is the user. So this parent resolver returns success and user. User is defined as a user type. So GraphQL knows to look here in the user type for what it's trying to determine is valid. It says, okay, I need to get an email and a favorites. And so it then says, okay, I've got my email and my favorites is a function that's going to now receive the parent, where the parent is the user that was just sent down to it. And this is how you can have this cascading tree of queries saying, well, I got the user that this song belongs to, so now let me get all of the songs that this user owns. So this concept of nesting database calls is how you're able to have a data graph, right? This concept of querying by relationship without actually having the complex like graph database implementation. We're using SQLite, right? We're using the most simple relational database you can think of, but we're getting all of this power of being able to query by relationship purely because we're describing these schemas and the ways to get nested fields within them. So one thing to note about that is that it is really chatty, right? If you think about what we're doing, we're not just getting all the users and their songs in one query. We're going and getting the users, and then we're going and getting the songs. And that, at scale, can become a really active code base. So for that reason, it's why I said at the beginning, optimization is an integral part of using GraphQL in production. You don't just throw up a GraphQL architecture and then wipe your hands of the whole situation. You have to actively use the tools that have been provided to monitor, to see, the favorites are requested all the time with the user. So instead of me having this separate favorites resolver for the user, I'm going to satisfy it up here from the get-go with a more efficient query that gets all the data all at once, and I'm not even going to have this favorites key in the first place. So, okay, with all that said, let's dive into the user service. Go over here, go to the user service. So what you'll find for each of these is that we have, we have two folders. We have a start folder and a finish folder. The start folder is going to have a series of files that are already built that handle some of the underlying logic. And then it's going to have empty files that are the ones that we're going to work in that I think are the most illustrative of the points that we're trying to get across. So the the first, if anyone is following along, the first tag that we're going to check out is get checkout to-user-start. And if you say get tag-l, you can see a list of all the tags, and you can just run through them chronologically. Okay. Let us first go to I'm going to put this pen down, go to the first commit, and I'll do it this way, get checkout to-user-start. All right. And let's bring it over here. Okay. So first, let's look at the top level index file of our server. This is the basic Apollo server. The first thing that we're doing is we're getting our environment variables loaded up. That's like pretty standard, right? The next thing that we're doing is we're calling Apollo server from the Apollo server package. This is just a logger, right? So like instead of using console log, if you were in production, you would almost certainly be using like a logging tool. So that's what this is. And then what we have are our type definitions and our resolvers. So the type definitions are the schema. The resolvers, as we just talked about, are the resolvers. So you feed that schema and those resolvers to the Apollo server, and then you tell the server to listen on a given port. And then when it's ready, you can log that the server's ready. Easy enough. So let's look at what the schema looks like. This is a schema. And I'll make it a little smaller. Is that still legible? No? Cool. So what we've got here is a simple function called GQL, which is also provided by Apollo server. And it's got a kind of interesting syntax. You just feed it a backtick, which starts this off as a string. And then you have your whole query, or your whole schema, and then the closing tick to close it all off. So what we've got here is a few things. We've got a type query that takes a user ID, right? We've got a mutation for signing up and a mutation for logging in. Those both also accept emails and passwords. We have a user response, which is success, message, token, or user. It can provide all of those things, with the only thing that it always needs to provide is success, failure, or a success of true or false. And then the last thing we have here is a user, where the user has an ID and an email. So we've defined what we want our user service to be able to do, and we've defined the interface that others are going to use to ask for these things to happen. So the next thing that we're going to have to do is write the actual functions that make this work. So if I were to open the resolvers right now, this is the basic structure, right? So we've got the query with the user type, the mutation with a sign up and a login. That's it. Nice and easy, right? So you'll notice that these are all asynchronous. I'm just leaving it that way because they will actually be fully async functions in a minute. And these are the arguments that they receive, right? So the first argument is nothing, right? Because it's the parent, and in both cases, this is the top level resolver, so there is no parent that it's receiving information about. The next argument is the arguments that it's receiving from the client, which if I were to split screen this, right? So we have an ID here, and we have the ID here. We have an email and a password, email, password, email, password, email, password. Making sense? It takes care under the hood of this consistent naming for you. And it just returns, it passes everything around as an object with consistently named keys, which is very convenient. So this is the basic setup for a GraphQL server. So if we wanted right now, we could get this going, and it should just run. It'll be useless. It will do literally nothing, but it exists now. So now what we can do is move on to the next step. And this is going to be get checkout to user resolve user. So we're now going to add the resolver logic for the user query. So there's no need to really look at this anymore because we're done with it. So let's look at, close that and bring up the data model, the user source. Okay, so this was empty a moment ago, right? What we've now added is a function to actually resolve the user query. So what we're doing is we're saying I want my user to equal a fetch of my user by ID, and I'm going to either return a success of false with an error or a success of true with the user that I just fetched. So now here comes this third argument, which we haven't talked about yet, that I mentioned briefly, called context. So context is a thing that Apollo provides per request. So when a request comes in, it's going to get a context on the front end, and then whatever context you've set, now it persists across the lifetime of the query. So as things are percolating through the GraphQL architecture, you're going to have access to this thing consistently. So where this is created is at the top level. So where before we had simply, and I believe I can go back, yeah. So where before we had this really basic server that had our schema and our resolvers, what we now have is this additional thing called a data source, which is a function that returns an object, and that object is going to be what's passed along through the duration of the request as part of the context. So in this case, what I'm saying is that my user API is going to be this instance of the SQLite database ORM that we're using. And if you're curious, you can look at it, and this is what the model is, right? It's just a really simple SQLize object that provides information about a user. We're not going to go into that. If you're curious about SQLize, check it out. It's very useful. So what we're basically saying, though, is I want to have an API that lets me query the user database, and it's going to be made out of this model. So the other piece of this, right, so I've done this create models, which is provided by SQLize that I just mentioned, but the second piece is that I'm actually feeding this data to this thing called user API. So user API is coming from this data sources/user. And if we bring it up, this is a special class that we've created with the help of Apollo. So this is a little bit of an over-architected thing, it seems, right? Like I've got this instance of a class that's being based off of a SQLize model. Like, why are we really doing it this way? The reason that we're doing it this way is because we're buying in hook, line, and sinker to the Apollo infrastructure. What Apollo is giving us here is a set of functionalities that we're extending from this data source class that Apollo provides. And what the data source class does is it automatically handles caching and deduplication and error handling. So what it means is that if, like, you'll notice, like, I'm not doing any catching anywhere in this code, right? I'm not trying to fetch my user and then if it goes wrong, logging it and throwing an error. Under the hood, because we're using this data source class to extend our user API, anytime one of these functions throws an error in the user API, it's getting handled by GraphQL or by Apollo under the hood. It's going to, you can have it integrate with logging architectures. It will send a very descriptive error to the consumer client that's like a pre-supported syntax. So it's really just wrapping everything up nicely so that you don't really have to think about where things can potentially go wrong. It handles all of that for you. And in addition, caches things in memory such that if it receives a request to a given, query multiple times, it's just going to shoot the result back because it was storing it in memory anyways. So it provides a lot of quality of life improvements that, again, for a contrived example is a bit over-architected, but in application, it can be very handy. So I'll just go over very briefly what we're doing here because you'll see this pattern throughout all of our code. We pass it the store, right, which is what we did here. We passed the new user API, the store object. And we say this .store is equal to the store. And so now what we're able to say within any of these functions is this .store .users .find one, where the ID is whatever. And then we can return a standard formatted user, or we can return an error of no user if that user doesn't exist. And so one level up now, we're either going to receive back a user object, or we're going to receive back an error object, right? So if user.error exists, then we'll say success false. The message is equal to user.error, which in this case is no user. And we'll say, again, success false. Otherwise, we'll say success true, and we'll return the user. Makes sense. So the next thing we'll do is we'll look at what, yeah.
Was that an Apollo object?
Yes. Or no, excuse me, I'm sorry, that's a SQLize object. It's simply a syntax that I chose to go with. If I wanted, I could just call that directly in the instance of the class. You can do it a number of ways, but I chose to do it this way because it's consistent with the docs that Apollo provides, and I wanted to try to have this be as like similar to other examples as possible. So that's why I did it that way.
Does Apollo know about SQLize?
No, not inherently.
You can pass it anything.
You can pass it literally anything. Exactly. So let me check out to-user-resolve signup. So now what we're going to look at is the resolver here again, where we've now added a second function, the signup function. And we'll also have added a new functionality to our user API to sign a user up. So again, we receive an email and a password and that data source context. And we're going to first try to sign a user up. If there's an error, we'll return success false with the error. And if there isn't an error, then sweet. Let's return a token, which is going to be a JWT token, and we'll return success true along with it. If you don't know about JWTs, long story short, they are a way of encoding information from an object into a string that you can then send that string around. So on the client will have this JWT that serves as its identification token. And anywhere we want, we can decode the token to see its contents, but we can't edit its contents. If we try to edit the contents and then reassemble the string will be a garbled mess, and our validation is going to catch that the string is a garbled mess. So it doesn't ensure that no one can read the data, but it ensures that no one can update the data. So this token is going to serve as our identifier, which we can easily parse apart to get information when we want it, but we can also safely use as a way of saying it's definitely a user with ID 1, or it's definitely a user with ID 15, because that's the value that's inside of this parsed apart token. And here is the signup function that we have just added. So if there's no email or no password, then let's return an error. Otherwise, we have data, so let's make sure that that user doesn't already exist with that email. If a user does exist with that email, let's return an error saying already exists. If they don't already exist and we do have enough data, then sweet, let's create a salt and a hash, which I won't even go into that, but it is a safe way of storing passwords. We can leave it there. So I'm creating a salt and a hash for the password for the user, and I'm storing that user with their email. And I'm returning that newly created user that, again, is going to have the same format of an ID and an email. So one thing that you may have noticed is that I'm saying if no email or no password, yet in our schema, it kind of seems like we were already checking for that. We were saying if it doesn't have a string of a password and it doesn't have a string of an email, then you need to throw an error before you try to do anything. That is true, but the catch is that at least in Apollo's implementation, an empty string satisfies that check. So someone could theoretically submit an empty string for an email, an empty string for a password, and GraphQL would be none the wiser, and it would say, oh, I received a string, so we're good. So this is me checking for the the falsiness of an empty string, right? Because an empty string will show up as falsy. So we can catch that situation here. So you'll see that pattern throughout, even though our schema is guaranteeing that some form of password and email exists, we need to ensure that it's not an empty string. Okay, so that's that. Now let's finally add the login functionality. So down here, again, you're probably seeing a pattern by now. Try to log in with an email and a password. If there's an error, return success false with the error. Otherwise, let's generate a token based on the user we just fetched and return that token along with success true. And as you've probably guessed from the previous example for signing up, logging in looks basically the same, where the only difference is that we're now also making sure that the user exists, and if they don't exist, then that's the error, right? As opposed to a user existing being the error. So I can basically just move past that now. So what we've got with all of that is the full user service, excuse me. So if we go here, this is the GraphQL interface that Apollo provides. So when I'm running my Apollo server locally, I have access to this at the localhost location that I've created. So the first thing I'm going to actually do real quick is create my database. So let me cd into user start and npm run db create. All right. Now let me go back 2 levels to the music service and then start and npm run db create. All right, so now our database file is all nice and put together and ready to start saving stuff too. So these are pre-written queries that I've already got here for the user service. So the first one we've got here is a user query. So again, I could call this literally anything I wanted. It doesn't matter. But I'm calling it user for the sake of consistency for the user query that I'm writing inside of it. And again, here is an example of that tooling, right? It says that it's a failure code. And it knows that it's a failure code because of that single quote notation that I added in my schema saying the message is a failure code. So first, let's try to get a user with an ID of 1. And you can set query variables over here. And I've already set the ID of 1. And this ID here corresponds to the ID I've defined here. And I'm going to get a thing telling me false, success, no user. Sweet. All right, that makes sense. What if I try to log in with this email and this password? Again, false, no user. And the login is the key that we're getting here, and user is the key that we're getting here, right? Because it corresponds to user and login. And so in practice, what you'll see in a few minutes is these are the queries that our UI is going to have. Our UI is going to make these exact same structured queries. And if I were to try to do something like fake field, well, one, it's going to throw this and say cannot query the field because it doesn't exist. But if I were to try anyways, it then gives us a descriptive error saying cannot query the field on type user response. And if I were to just request a user, which is a nested object, it's again going to complain because a user is an object type that has subfields. So I need to specify at least one that I want to get, even if I'm not getting a user at that moment. So let's actually do a thing that works. I will sign up. All right, it worked. So we have this JWT encoded token. So now what we can do is in the future, if we want to, we can just log in and get access to this token again. So now let me try to get that user. All right, it worked. And it says that I have an email of test@email.com. And if I try to sign up with that user now, it's going to say false, already exists, right? So you can pretty quickly get a lot of functionality and like a pretty descriptive API with pretty minimal effort. And this descriptive way that you're able to look at a schema and automatically know what is possible and then have that guarantee percolate down into the code itself, it does mean that everything's very coupled, right? So like, God forbid you need to move away from GraphQL in the future, like it is going to be a pain. And that's something to consider, that this is not like a decision that you should take lightly, because it really does reach from your user interface all the way through to your database queries. Like you are really locking yourself into certain data shapes. But it's why the initial discussion of what the schema needs to look like is a very important one that shouldn't be like the afterthought. It needs to be a major part of your planning process is what is this going to look like and how can we design it such that it's flexible for later? Okay. So let's experiment with GraphQL. I think it's fair to say that we just did that. Here's a few prompts that you can come back to later, right? So what happens if you don't request nested data? What happens if you query a field that doesn't exist? You should play around with trying fields that do and don't have exclamation points and see what happens as you mess with the requests. So now I know that we've been going for like already an hour. Let's take like a 5-minute break to just like loosen up, go to the bathroom, get a drink, get more pizza. There's lots. And then we'll resume in 5. What?
A very
Yeah, it's got to be a strict 5. Alrighty. Okay. I'll give you all a few seconds to get situated. Okie dokie. So the next thing that we're going to do is we're going to build the music service, which is, as you'll see, going to look very similar to the user service. It's going to have a few little small tweaks, but it's going to be largely the same. So let us go to the music service. And again, there's a start and a finish folder, right? So the start folder is going to have a few files that are empty, and then a few files that already have all the stuff in it. And the finish folder is going to have a fully finished version of the application. And if at any time you're curious about all the tags that are available in this repository, those are all of them. So we've moved through the user setup, and we're now into the music. This is not chronological within the section, right? It's alphabetical. But if you use the supplemental doc that I linked to, it lists them all in order and talks about each of the files that have been changed. Okay, so let me open the several files that we're going to update here. So the first is going to be the music services top-level index file. The second one is going to be the schema file, right, just like we had before. And the third one is going to be the resolvers, just like we had before. So let's get checkout 3, music, start. So just like before, we've got our basic server with our logger, our schema, and our resolvers. We're listening on port 4001 instead of 4002. And we've got a schema with a bit more stuff going on. And we have our resolvers. So I'll talk very briefly about this. It's conceptually extremely similar to what we just went over. The one or really two things I would like to note here that are distinct. One is that we have a query up here called recent favorites that doesn't actually return a song response. Everything else returns a song response purely because all of these other things have the potential to fail in different ways. Like a song receives an ID, so you're trying to get a song of a given ID. Well, maybe that song doesn't exist, so I'd like to have a descriptive error message. And maybe the adding the favorite, you give an artist but no name and no reason. So I'd like to be able to give a descriptive reason for why it failed. But in the case of recent favorites, all we're getting is a list of the 20 most recently favorited songs. There's nothing to uniquely go wrong. If it's failing, it's just failing. So I'm not going to send a success false. I'm going to get that complex looking GraphQL error that we saw a minute ago when we saw here, if I were to do this and try to sign up, we would get this kind of involved query error that says here's a stack trace and everything that's gone awry. This is what we would see in the case of the recent favorites failure. The other thing I'd like to point out is that this uniquely has the enum type that we talked about before. And those are really the only two distinguishing features. Otherwise, it's very conceptually similar, right? We have queries and mutations. We have song responses instead of user responses. We have songs instead of users. So looking at the resolvers, again, very conceptually similar. We have our query object and our mutation object. And within that, we have the recent favorites and the song, and we have the add, update, and remove favorite. Okay. So that's the basic structure. So let's move to git checkout 3 music resolve recent favorite. Okay. So looking here, again, we've got a data source. We've got the song API that we're creating. We've got the store that we've created with Sequelize. And in our schema, nothing's changed, so I'm going to put this over here. In our resolvers, we now have our first query, our recent favorites, right? So data sources.songapi.recent favorites. We've got lyrics, which we haven't touched yet, and we've got song. So song, just like before, is a data source. It's got a store, and now we've got our functions that we're going to return stuff from. Recent favorites is going to return all of the most recent 20 songs ordered in descending order based on their created at property. So this is, again, just returning an array of formatted songs. And this is what a formatted song looks like, is it's going to have a created at, artist name, reason ID, and user ID. And I recommend that when you write these classes that you have a object formatter that makes the returned shape consistent, given that our schema is relying on a consistent shape coming out of this thing, right? So you don't want to manually rely on hard coding that every time. Throw it into a function that handles the formatting for you. Okay, easy enough. So let's look at what the next step looks like. Music, resolve, song. Okay. So now we've got a bit more involved logic going on here. The first thing is we've got a ID coming in, right? So we're going to try to find by ID. If there's an error, let's return false with the error. If there is a song, then that means that we can get the artist and the name out of it. So the next thing that we're going to do is we're going to use the artist and the song name to go to the lyrics API and fetch that song's lyrics. You might notice in this implementation that I'm saying that if lyrics exist and there's a lyrics.error, then I'm going to return success false. That means that if our API fails to find lyrics for a song, that it's going to say that the song failed. So this isn't going to work super great with instrumental music. Sorry, classical fans. So if we look at the song class, we now have find by ID, right? Pretty standard compared to what we've looked at already. So this.store.songs.find1, where the ID is equal to ID. And if there is a song, format it. And if there's not, return an error for no song. So let's look at the lyrics API. So this is going to be fairly similar to what we were looking at a moment ago with the data source for song. But what you might notice is distinct is that this is a REST data source. So this is from a separate but related library called Apollo Data Source REST. So they've really thought of basically everything. And so this is me, again, just playing nicely inside of the paradigm that they've developed. So it provides a lot of that same functionality that the data source class gives you. So caching, deduplication, error handling, all that nice stuff. And you can also set a base URL. And it automatically is configured such that if you say that this is the base URL whenever you instantiate the class, then you can simply call this .get or this .post and those sorts of things. And because it's an extension of the REST data source class, get has a particular meaning, and it's going to be based upon this base URL. So we're using this nice, really handy free lyrics API where all you have to do is shoot over the artist/song name, and it will return to you an object that contains lyrics, which is really handy. So again, I'm actually trying and catching here, not because I don't want to show an error, like that verbose error, but rather because I would like this to fail quietly if something goes wrong. I would like to just return null if there's an issue, right? So let me go back. So that is pretty much everything for the query component of the song API. Is everyone following so far? I know I moved more quickly through that, but yeah? Cool, all right. So let's check out the next thing. 3, music, resolve, add favorite. All right. So we now have this add favorite functionality, and we're going to talk about 2 things that are special here. The first is that you might notice that we're now getting another thing out of our context called the user ID. And we're saying, if there's no user ID, throw a forbidden error saying that you do not have permission to make this change. And if this error is not thrown, let's go on to add that favorite song. And then again, that same syntax of if there's an error, return false. And if there isn't an error, let's return true along with the song. So where did this user ID come from? It is a part of our context. So where did this context get added? It is part of this fun new little thing that we just added to our Apollo server called context, right here. So if I go back a step and back forward, right? So what we're adding is this context key. And because Apollo is super smart and does lots of stuff for us, this is simply a key that expects a function, and that function receives an object. And one of the keys in that object is the request coming from the user. And so what we're saying is we expect the headers to have a user ID header. And so we're saying that the user ID is equal to the user ID header. And if it exists, let's return that ID as a number. And if there isn't, let's just return null. So what this is saying is if we receive a user ID header, we are going to return this context that is then going to persist through the duration of the request. And if there is no user ID header, then we're just not going to try to provide one. And we'll leave it up to individual resolvers to determine if it's a problem that there isn't a user ID. So for instance, in our first two resolvers for recent favorites and looking at a song, we don't care if there is or isn't a user ID in our context because those aren't things that require a particular permission. However, in the case of the adding a favorite, we don't want someone to be able to just say, oh, I want to submit a new favorite for user ID 4, right? We want to be able to establish definitively that it's, the user that they are claiming to be. So right now, this is super insecure because we're just saying, shove an ID in the header and we'll believe you that that's the proper ID. We'll see in a few minutes that we can add some authentication to ensure that this ID is actually the ID that we want it to be. Okay, I'll move on to the song. And again, add favorite is the thing that we just added. If there's no artist, no name, and no reason, then we will throw an error saying incomplete data. Otherwise, let's create the song using that user ID and everything else, and then return that formatted song. So let me bring my notes. Pass the first page, y'all. We're doing it. Okay. So get checkout 3. Yeah, cheering section. So let's do, 3 music, resolve, update, favorite, okay? And I'll stop here for a second just to show you that we now have at least basic functionality on our music service. So if I were to try to get recent favorites, oh, I need to actually turn it on. That might be helpful, huh? Dun, dun, dun. There we go. All right. So get recent favorites. It's empty. I know, disappointing. Get song, false. There is no song. It is a lie. So let's add a favorite song first. So I've already pre-filled out the information that we're going to feed here. So this is a kind of long query, right? But what we've got going on is a mutation that we're arbitrarily calling add favorite just because we would like it to be consistent and understandable to a human reading it. And it's going to receive the variables artist name and reason. It's going to then pass those on to the actual add favorite mutation. And as you can see here, the add favorite mutation returns a song response. And by the way, the schema button over here, you can click at any time to see your schema, which is convenient. So just so y'all know. So let's add the song that we've got here. And if I were to remove this, it's going to yell and say that the variable name is not provided. So let's add it back. If y'all haven't listened to this song, it's very good. Highly recommend. Add favorite. Yay. All right. So now we've got back our song with the ID, artist name, and the reason that we liked it. Note, like I said before, IDs are stringified. So even though this ID is a number, it's being cast into a string by GraphQL. So now that we've added our favorite, let's get the recent favorites. Look at that. We now have access to it, and we can dynamically tell our database, or excuse me, our API, what information we actually want. And this is the power of GraphQL. You don't have to update an endpoint. You just update the request, and that's a lot faster, right? Because if you're updating the endpoint to match the UI, you're already updating the UI. So with this paradigm, all you have to do is ever update the UI if you've designed your backend flexibly enough. Okay, so now let's try to get that song. And again, here it is. We've got success true with the artist, the name, and all the lyrics. Cool. So we now have a basic, minimally viable, functioning API. The next thing that we're doing is we're adding the ability to update a favorite. So you'll see that this pattern kind of looks exactly like what we were just looking at, right? So we get the user ID out of our context. If it doesn't exist, let's throw an error. If it, excuse me, if it does exist, then let's update the favorite using that ID and then return an error if there is one. So this forbidden error that we have here is provided by Apollo and is, again, just another example of me playing within the paradigm that they've established. It is by no means necessary, but when you do it this way, watch what happens if I try to update without a user ID. So I'm going to call update favorite, and it's going to say that you don't have permission to make the change. It's going to give a description of where it happened, and then you get this like standard code. And so when you use any of their error classes, and they have a bunch of them, this becomes a common syntax that you can always expect, that you can then use to pass off to error logging and whatever else that you want in a consistent manner. So if I go back and I add my user ID, and let's say I change it to user ID 3, which I know is a user that doesn't exist, and I say update favorite, it's going to say invalid song because no song with the given ID that I gave of ID 1 exists with a user ID of 3, right? So let's do user ID 1, update favorite, and true, it permitted it to go through. Hooray. Okay. And looking back at the song class, again, same idea. Let's update it. First, let's find it. If there's no song, return no song. If the user ID is not equal to the user ID that we're getting, then let's say it's an invalid song. And then let's update when all those other paths have not been hit. Okay, so we're nearing the completion of the music service. Get checkout 3, music, resolve, remove, favorite. Okay. By now, you've probably been able to figure out what this is doing. Standard compared to what we've got for the others. It basically looks like I copy-pasted because I basically did. And the remove favorite, again, looks pretty much the same, right? Try to get it. If it doesn't exist, then no song. If the ID doesn't match, then it's an invalid song. And now let's destroy it, and then let's return it just in case the user is like, oh crap, wait, I really didn't mean to do that. We've now provided a path back for them to at least try to add back the song. Okay. So that is the music service. Okay. So that music service went pretty quickly because it followed a very similar paradigm to the one that we used in the user service. But it's about to get a bit more complicated. So bear with me. And if any of this doesn't make sense, don't worry. There's a lot of documentation that I provided that you can come back to. Also, my email's at the end of this slide. Like, I like talking about this stuff, so if you have questions, hit me up. Like, I'll happily talk about it. So schema federation is a very nerdy-sounding term that means that you are splitting up your schema to work across separate services and then having that split up schema recombined by a central server somewhere. So what does this allow us to do? Why would we want to do it? The two main reasons are that if you think about, if you're familiar with the microservice concept of a separation of concerns, this is like the standard way that you structure applications now, right? Is you have a series of small services. Well, with everything that we've just been doing, you can start to imagine a world where pretty quickly, like what, are you gonna duplicate the schema in multiple places across different repositories? Are you gonna have like a schema repo that you then like have other applications consume? It can get kind of messy if you start trying to have this like single source of truth that all of these different microservices are trying to consume. So schema federation is going to allow us to have a true separation of concerns. And it's going to still let us have all the nice benefits that we've gone over already that GraphQL provides. The other benefit here is that by the way that it's been implemented, each of these services is going to be able to work minimally on their own, even without the gateway stitching it all together. And I'm sorry, I should be explicit with my wording. There is a specific thing called schema stitching. That is not what we are doing. Schema stitching was the old, I mean old if any of this can be considered old, the old way of doing it all of 6 months ago or whatever. But federation is like their solution because they found stitching to be a really obnoxious and clunky process. So I do not mean to say stitching and do not look up stitching because that is not what we are doing. We are doing schema federation. Okay, so the building block of federating a schema is the concept of entities and keys. So we've had our user type and our song type. A entity is a type, that's all it is. And it's a type that's being used in multiple places. So for instance, our user is going to be used in our music service. Our music service is going to say, I have a song and that song has a user. So now the user is an entity. It's not that it's now no longer a type, it's a user type. It's just also now called an entity. So the way that we define entities is with the @key directive here. So we talked about directives already, right? That the @if and the @includes and @skip. So this is a new directive that Apollo's providing themselves and that they're recommending to like the GraphQL specification committee or whatever. And so it's in progress, but they've fully implemented it with their own libraries and have made it relatively easy to use. So we're gonna use it today. And it's provided by another separate library called Apollo/federation. So this @key directive, what it does is it accepts one argument, and that argument is used by other services to identify that entity uniquely. So for instance, our user has an ID and it has an email, right? So what we are defining now, instead of just saying type user with ID and email, we're saying type user @key has fields of ID. And what that means is, okay, everyone else that is going to try to use the user type, you're going to be able to uniquely identify the user type based on their ID. It's pretty self-explanatory, pretty obvious that that would be a way to do it, but you need to specify it because maybe it's a UPC code, right, if we're talking about products, or maybe it's a combination of email and ID if you duplicate IDs, I guess. But either way, what you are specifying with this fields argument are the fields that other services are going to be able to expect to receive to use and treat this as a unique thing. So the other services that are going to use the directive, right? So we defined the user here in the user service. Now in the music service, we're going to extend that type of user. And we're going to have the exact same syntax of @key fields ID with the ID field as external. And then we're going to add our own key. So notice that I didn't put email here because the music service doesn't care about email. It's not tracking information about emails. All it knows is that a user has an ID because we've defined it with this fields argument. And the music service knows that it wants to add favorites to a user. So that is this underlying concept of each service knowing only exactly as little as it needs to uniquely identify a type, and then adding its own stuff onto that type is how schema federation permits schemas to work independently, but also together. Because now you've identified a thing that permits them to work together and identify a user consistently, which is the ID, and so they can all share this source of truth. And by the way, if I were to say fields, email here, and then in the user service say fields ID, when you try to run it all together, it's going to explode because it's going to notice, hey, you said in one place fields email, and in another place you said fields ID. This doesn't work. So that is the one way where coupling starts to happen between services, is that you have to have the same syntax for this fields argument. So this minimum, actually, so I should go back and explain one thing really quickly. So and I'm going to read it directly because this is like an important phrase. So in other services that refer to this entity in their own schemas, so in other words, in the music service, where we refer to the user entity, we define a minimal viable version of that entity called a stub. The minimum viable version is the fields that we've identified as uniquely identifying it, right? So it's ID, that's the minimum viable thing that you need to define a user. And you then are adding on whatever else is needed for the schema to minimally function within the context of whatever service is doing it, in this case, the music service. So this minimum viable version of this entity is then used as the basis for the service minimally functioning whenever federation is not being used. So if I spin up the music service and I request, the favorites key from a user, I will now at least have the minimum stuff I need to make that happen. And it's also important to note that with this implementation, when you have this minimum viable thing being established in two different places, that is what's getting sent around from service to service. So as we'll see in a second, the minimum viable entity is what is sent from the music service off to the user service. So you could add 10 other fields if you wanted, but the only thing that's actually getting sent is going to be whatever fields you've described as the arguments. So favorites doesn't even get sent with the user over back to the user service. The only thing the user service is going to receive back is the ID, because we said that that's the minimum thing that you need to make this thing work. And that's how it tries to cut down on data consumption, because otherwise we're going to be having stuff go back and forth a lot. So we'll see in just a second how all this fits together. So bear with me here. The fields that we define for an entity are used as a unique identifier, right? Which we just said. And they're what is passed around to our resolvers across services, which is the other thing that we just established. So the thing that the actual object that gets passed around is going to be those uniquely identifying fields, in our case, ID, and this special variable key that gets tacked on automatically by GraphQL or by Apollo called type name. And in our case, it would be user. And it's this type name that GraphQL is then holding on to and tracking and saying, okay, I got this type name user from the music service with an ID of 1. Let me go over to the user service and ask for that same type name, AKA type, user type, with this ID. And now I know conceptually that these two things are linked. So this is the minimum object that is sent around from place to place and is how this tracking occurs. This might seem like it's in the weeds, but it's very important because we're actually going to have to manually tell it to do this. So in the user service, we have our user key with the field ID. And then in the music service, we have our song like we had before that has a user key in it. And we are going to say that the user is extended from the base user type, and it is going to have an ID, which is external, and it's going to have an array of favorites. And then in our resolvers, right, so normally you would have query and mutation and whatever else, we now have a unique resolver for song.user. So, right, we have the song type here, so we have the song resolver here, and we have the user field on a song, so we need to resolve what the user field is. And so we say, okay, the minimum viable thing that is going to be sent around whenever we need to get information about a user is going to be the type name user and the ID is going to be the song of the user, or the user ID of the song, right? So this is how some of this microservice simultaneous with like relational database stuff starts to happen, because a user ID is a foreign key, and under the hood, our SQLite database has a foreign key of user ID. But after you get above the resolver level, when you're up in the schema level, that's no longer necessarily what you're like exposing to the outside world. All you know is that there's a song and a song has a user, and that a user has a song, right? So this is how we're defining these relationships in a tree structure that is, circularly referencing as well as flexible. So the last thing to talk about here is the __ resolve reference. And don't worry, we're gonna put all this together in just a second, and hopefully something will click, or maybe it will explode, I don't know. So the resolve reference function is a special function that's used by the original service that defined the entity. So in our case, the user service defined the user entity. So the user service is going to have the user resolver, and it's going to have a special function inside of it called resolve reference. And as the name sounds like, its job is resolving more information about this minimum viable thing that we've sent off to it. So we could have 50 other services. All 50 of them would need to be returning something like this for the user key, or maybe exactly like this for the user key. So this resolve reference would be receiving all of these different objects from different services, but it could expect every time to have an ID, because we've already established that that's the unique field that establishes what a user is. So we get the ID out of our arbitrary service object. We find the user by that ID. If there's no user, then we're just going to return null. We're not going to return like message and success and error, because that's not what this is about. This isn't about returning the full-shaped success, true, false, message, if there's a failure, and then all that. Its job is give me a user if one exists. So if we don't find one, let's just return null. Otherwise, let's return everything we got out of the service plus the user that we just got. And that is then all sent back to the gateway that then stitches it together with everything that it was still holding in memory, and that's what gets shot down to the user, or to the client. So putting it all together, someone makes a query called getSong, right? So we hit this song query, and we pass it an ID. We ask for success and message, and if it succeeds, a song. Within that song, we want not only the artist and the name, but now we would like to know what user owns that song. So we say, okay, give me the user of that song, and let's see their email and their ID. All right, well, now that we've done that, in the front end, we need to have our schema match that, right? So the music service is gonna handle it. So we have our extended query, and we're extending the query everywhere, by the way, as you'll see in a moment, because query is now a type that's shared everywhere. Like every schema has a query and every schema has a mutation, so we need to extend it everywhere. So we're extending the query type. We have this song query that returns a song response, right? Pretty standard stuff that we've been looking at now for a while. And over here, this is where the rubber starts to meet the road. This is our resolver for the music service. We've got our song, which returns a song. And I simplified it to just be success true, right? Like, let's just not deal with the error cases. And then the song resolver gets hit, right? Because we have this song object, and the song is asking for a user, and it's going to return a type name user and ID song.userid. And actually, I'm seeing that right there as a typo. It should be a lowercase u, sorry. So the final thing is the user service is going to handle this. So this minimum viable stub that we just got, plus all the other information that was just generated from up above, right? And by the way, this song is the parent, right? So this song is what triggers calling this type, this resolver. So the function expects to receive the parent song object that it was just attached to. So we have the user ID from that song. So this minimum viable piece of data plus everything that we just fetched is sent up to the gateway. The gateway then says, okay, I've got my minimum viable thing plus this other data. Let me just send down the minimum viable thing to the other service that needs it. So I'm going to hold on to success true, and I'm going to hold on to the other information about this song. And what I'm going to send back to the user service for more processing is this minimum viable type name user ID of whatever. So it gets received, it gets processed, and we return the whole deal. This whole thing, again, gets sent back up to the gateway, and the gateway then stitches all of it together and shoots it down to the user. Does that make sense? Yeah? Oh, wow. That anyone's nodding at all is a feat in my eyes, so okay. So as I mentioned before, a note about optimization here, I just described like 5 back and forths for one freaking request. This is chatty. This is exactly why optimization is super important and why it needs to be a part of the process when you design any of these systems. If you're making it for fun like I did here, sure, don't use the tools. But in real world, you need to be aware of what queries are being hit most frequently and what you can do to improve the efficiency of them. Okay, so with all that said, let's build the gateway. All right, no thank you. Phase 4, okay. So there's gonna be 4 steps here. The first is that we're going to federate the user service, which is very fun sounding. All right. So let's open the index.js top level file. Let's open the schema file because that's going to change. And let's open the resolvers because that's going to change. All right. So git checkout for user federate. Okay, so what do we have? First, let's start at the top, at the server base level. So what we've done is we've gone from using an Apollo server to using an Apollo server with a build federated schema. So this is where the magic happens, and it's doing all of the work for us under the hood to add that @key directive to the schema and doing a bunch of other stuff that basically like injects the support code for the federation that we're about to do with all these custom directives. So that's pretty straightforward. The next thing that we're doing is we're modifying the schema here. So let me go back, and these are the things that change, right? So we extend the query and the mutation types, and we add the @key field here. And this actually should also be @external. But as you can tell, there's a lot of code to make this happen, so a few things may have slipped through the cracks, so I apologize. The last thing to note here is that under the user resolver, we have resolve reference. Oh my gosh. Sorry. Okay, yes, I'm getting ahead of myself. Yes. So under the user resolver, we have resolve reference to resolve these service objects, right? Which is what we just talked about. So this is all that we needed to do to enable our service to be federated. And I did say that it needs to be external. It actually doesn't need to be. I was thinking I was in the music service. I'm getting my stuff crossed, people. Bear with me. So this is actually all right. We're good here. No, nothing else to see. So what we've done is we've added the build federated schema. We extended a few types and added this key. And we added the user, all right, with the resolve reference, which can handle this service object coming from other services. Pretty straightforward. Or maybe clear as mud. I don't know. You tell me. So the next step is going to be federating the music service. You'll see that it goes pretty similarly. So let us say this, the schema file, the resolver file, and the song data source. So let's say git checkout for user, music, federate. Cool. All right. So just like before, what did we do? We added the build federated schema down here. That's pretty much the only thing that we've done. The next thing that we've done is we extended the query type and the mutation type. We added a user to our song, and we defined what a user even is, right? So going back and forward, those are the changes that were made, yeah? And here's that @external that I was thinking was missing a moment ago that was not missing. The next thing that we do is we add to our resolvers the song and user fields, right? So our song is now going to be able to support a user like we just defined, right? So a song can have a user, and originally we didn't have that, so we need to define a way for the user to get resolved. So we now say that a user is going to be resolved with a type name of user and the ID of song.userid. And we also say that a user themselves can have favorites, which is another thing that we've defined down here, right? And we're saying that we can get those favorites by looking at the song API, find by user ID. And so if you look at the song API, we added find by user ID. Is that making sense? Yeah? All right, cool. Do note that this concept of the user resolver simply returning the favorites key, because that's the key that it cares about, goes back to this idea of a separation of concerns and supporting a true microservice architecture, right? Because now, if it needs to, this schema can exist all on its own and exist all on its own and be tested all on its own. And it can know about how to add all of the fields that it cares about adding. And any other service, like let's say we eventually want to have, I don't know, we want to expand this to support like the favorite types of instruments that this person has or plays or something. So we could then add an instruments service, and instead of favorites, they would then add their own instruments key. And so now you can start to see that every service will control its little piece of the overall schema. So that's the federation of the music service. Pretty straightforward. The next thing that we're going to do is actually dig into the gateway. So let me open that, and it's all one file because with GraphQL being designed with a client-first mindset, if you've ever worked with a gateway in the past, what you've probably found is that you have to do a lot of work massaging data, right? Changing the shapes of data that you're getting from different services to then match some new shape that the client would actually like to consume. You don't have to really do that here because we designed the schema from the outset to work well with the client. So I'm going to git checkout for gateway start. All right, and so this is what we've got. We've got that standard load in our environment variables. We've got the Apollo server and the Apollo gateway. And we're saying that we want this gateway to look at these two services that we're going to name the user service and the music service, and they're going to run at these URLs. And then we're going to say that on startup, we want to load all of those schemas together, and we then want to pass all of this into the Apollo server. And note that there's this thing I put here that says subscriptions false. We haven't talked about subscriptions. It's yet another feature of GraphQL that lets you listen for live data updates, which is very handy. But again, as you can tell, we're already covering a lot here, so not today. But they aren't enabled for federated schemas. So I'm specifically saying do not allow subscriptions for the sake of explicitness. And then just like before, let's listen on a given port. So we're listening on 4000. So now we have our gateway on 4000, our music service on 4001, and our user service on 4002. And that's everything that it takes to get this basically going. So the next thing I'm going to do is add authorization to the gateway. And then our federation process will actually be done. Okay. So going back and forward, back and forward. Okay. Number one, number two. So the two things that I've added here are a context, just like before in our user service. And I also added this authenticated data source. And I'll talk a little bit about each of these. So firstly, the context. This context, just like before, receives a request object. And that request object has headers, right? So do note that this context that's getting passed around, or rather that I'm setting here, is not going to go to the other services. This is a context that's unique to the server, to the gateway. So what we're doing here is we are changing a property of the request if a certain value exists. So first we're saying, do the headers in this request contain a key called authorization? If the authorization doesn't exist, or the authorization is null, then let's just return nothing, and we won't try to add anything on to our request headers. However, or add anything to our context, excuse me. However, if we do have an auth header, let's validate it. And this gets to that JWT concept I was talking about a few minutes ago, where I said it's a string that can be parsed apart and read, but then if it's reassembled after someone tries to edit it without the proper permission, it will be broken. This is what that verification does. The verification parses it apart while simultaneously ensuring that the data was actually valid and not messed with. And if it is messed with, that means that someone's doing something naughty. So we're going to try to do it. And if we catch them doing something naughty, we're going to throw an authentication error saying invalid token, log in again. The other thing that we're doing if this doesn't happen is we're returning user ID in context, right? So just as before with the music service, where we were setting user ID based on the user ID header, we now are setting the context only within the gateway to include a user ID key. So the other thing that we've done here is that whenever we build our Apollo gateway, originally, if I go back, originally I was just building the gateway with the list of services. But now what I've also added in is this build service key, which is a special key that lets you hook into an entire life cycle of a request. So similar, if you know, hopefully you're familiar with React because we're about to do some React stuff. If you're familiar with, component did update or did mount, you have these life cycles of components. Similarly, you have life cycles of requests. So when a gateway receives a request from a client, it's going to trigger a whole life cycle of events. And one of those life cycle events is called will send request, AKA will send the request to someone else, another service. So because we've built the service with this authenticated data source that we're providing that receives the URL of the request, and that's just standard syntax that it asks for. What we're doing is we're hooking into this, again, playing just all within the Apollo world. We're fitting into the paradigms they've established and standard errors and logging and all the things that they provide. We hook into the will send request lifecycle, and we say that right before you send that request, if your context contains a user ID, then let's set the user ID header to that user ID. So now what we've effectively done is we've said anytime that a user ID is included in an authorization token from the client, let's parse it apart, make sure that it's real. And if it's real, let's shove that user ID onto the headers and send that off to every service that we were making a request to. And what that then means is that each of your services now has the user ID to work with, and it knows that it's the proper user ID for that operation. Does that make sense? Yeah? Sweet. All right. That is the auth. All right, so we're federated. Okay. Let me put this down. All right. Second page down. So let's go back to the presentation. Let's take a 5-minute break real quick because that was a lot. And we'll have a final like 35-minute dead heat to the end. All right? Cool.
So earlier you were talking about how Windows Apollo sort of handles the
The timer has gone. All righty. Let us resume. Okay. So, I know that hooks were like the other big part of this. We're obviously going to spend about a quarter of the time on hooks that we spent on GraphQL, but frankly, hooks are a lot less complicated, and GraphQL is a lot to digest. So I thought that it would be worth it to just kind of focus on that for a majority of this presentation. Either way, let's dive into React hooks. So, okay. The big question that I had whenever I was starting was, what are hooks? They've been talked about a lot. They seem to kind of operate magically because all of a sudden we're able to write functional components, but allegedly we have access to state and things like that. Like, what does that really mean? So to put it simply, hooks are a relatively new API for React, which lets you access the state, the lifecycle, and the other things that you associate with React classes in pure components. They're called hooks because they let you hook into React features. So how do they work? I'm going to read this obnoxious, esoteric quote, and then we can use that as a jumping off point. There is an internal list of memory cells associated with each component. They're just JavaScript objects where we can put some data. When you call a hook like useState, it reads the current cell or initializes it during the first render and then moves the pointer to the next one. So, to put it another way, anytime we call a hook, the result of that hook is going to be pushed into this list that React is internally tracking per component. So any call that you make to any hook is going to push a value onto this list on the first run through the component. Then, on subsequent re-renders, React is already under the hood tracking this list of hook values, and it is going to monitor and update them with each subsequent call to a hook. So there's nothing magic going on here that's giving us access to state and lifecycle. Under the hood, React is managing things for us, giving us the effect of lifecycle and state. It's also important to note that the way that hooks work, and this is going to be on the next slide, the way that hooks work, hooking into these underlying features of React to have the React engine tracking everything for you, means that hooks can't just be used outside of components willy-nilly. The very nature of a hook relies on it being called from within a component, because if you're familiar with what you're actually saying when you write stuff in JSX, like when you say bracket my component close bracket or whatever, greater than, less than signs, what you're actually doing is you're writing in a syntax that at runtime is getting transpiled into React.create component or something like that, React.component, and it's being passed as an argument to this React.create component function. So React.create component under the hood is what we're always using whenever we create components. So these functional components that we're now using are assuming that they're being called within the context of React.create component. So whenever you try to use these hooks outside of that context, they start to just not have any of the functionality that they originally expected to have surrounding them. So it's very important that when you use hooks, you use them inside of React. Additionally, like I said, because the order of the hooks dictates the order that they're pushed on to this list, you do not want to change the call order, which means you don't want to have a hook call be conditional. It needs to be called every time the component renders. And you don't want to have them happen in loops or asynchronously or anything like that. They need to always be called in the same exact order. And if it's called on the first render, it better be called on every subsequent render. So these are the rules of hooks. And there's even linting for these rules if you want. And so, by the way, if you click that link, it will take you to much more information. So the first hook that we're going to talk about is called useState. So useState is pretty straightforward. It gives you access to a variable which persists between renders, and then upon update, triggers re-renders, just like normal state. So whenever you call this useState hook, the syntax that you're going to use is const and then you destructure out two values from the returned value from useState. Is everyone here familiar with array destructuring syntax? Yes? Yes? Okay, sweet. So I don't have to explain. So the syntax here is the first element from the array returned is the value, which it can be named whatever you want. And the second argument is a setter specifically for that value. So what you can think of this as is a pointer to that memory cell and a setter for that memory cell. The use state then is also called with a default value if you want. So in this very basic example, we have a component that has a button that when you click, it increments up the counter of its state and it displays that count. So this is how you would use it, right? So you start it at 0, you get the count, and you get set count. So under the hood, the component gets rendered the first time, use state gets called. So now this instance of this component is being tracked internally by the React engine, and it has one memory cell associated with it. And that memory cell is a state cell, and that state cell has a value of 0. So because it's a state cell, React now knows, anytime the user updates this, I need to trigger a re-render. So this is how it's providing you access to what seems like a class-based state, when really what it is it's hooking into this underlying engine that React is always using to manage how things work. And by the way, I'm like 99% sure that when you use classes, that's what's happening anyways. It's just that they've now like removed that like sense of abstraction. So moving on. The next one that we'll talk about is use effect. So this is an interesting one. It's certainly more complex. We're going to go like 4 slides on it. This is acting as though you rolled component did mount, component did update, and component will unmount all into one. And it's used for code, as its name implies, that has side effects. And on that note, you'll notice that we've just talked about use effect and use state. The standard practice is that any hook starts with the word use, because you're using a feature of React by hooking into it. So, so we call it use effect or use whatever. So the syntax here, it doesn't return anything. All it does is it expects a callback that it will call at some point in the future and a comparison array, which we'll talk about in a few minutes. So to expand upon the example that we had a minute ago, first, we set our state to 0, and then we have this use effect, which is saying, okay, over the life cycle of this component, after it's mounted, when it updates, and when it unmounts, let's subscribe a given name that we received in our props to some API, which is a horrible idea because we will subscribe on every re-render, but bear with me. Okay. So the use effect callback, aka the first argument that you pass to it. This function, because ultimately a component is just a function now, every call to render our component is going to run through this every time, right? So that means that the next time this component runs, this callback is actually going to be a different function. But that's actually okay, and it's actually important that it behaves this way. What we'll talk about in a moment is how, because you're effectively passing a new function into useEffect on every subsequent re-render, the useEffect is able to hold on to the older version of that function with old props and old state values and old everything, and then work on it as though those values haven't changed in a new subsequent render. And if that's confusing, bear with me for a minute more. Also do note that just like I mentioned that the order of the hooks, as you call them, matters, the order of useEffect callbacks is also the same. So useEffect 1 is going to have its callback called first, useEffect 2's callback is going to call second, and for that reason they can't be asynchronous. Okay. So the next thing that we're going to talk about is the useEffect cleanup, aka the thing that you can do to clean up whatever you've done in your effect. So you pass useEffect a function, a callback function, and that function can itself return a function. So this function is called the cleanup So in this case, we are on, when the effect first runs, we are subscribing to an API with a given name. And then on cleanup, at some point in the future, we are going to unsubscribe the API for that name. So the way that this is called is that it is called right before the effect is called on the next render. So let's think through this real quick. Component mounts and returns this button. So component did mount, okay? So now useEffect's callback gets called the first time. And now it returns this function that is now indicated to react as cleanup, but that function isn't called yet. So we've rendered once, did mount. We've subscribed to our API after we've rendered for the first time. Okay. Now someone clicks the button and the counter increments up. Now the re-render begins again. Count is now equal to 2, or I guess it would be equal to 1 now. And right before, so we return the new updated value of the count now being 1. And now, before we call useEffect's callback again, the new one that we just defined, this old callback that we returned earlier gets called. So you're going to call the cleanup from the previous render right before the next useEffect gets called every time. And that's why we're operating with these as callbacks, right? They're deferred code calls to sometime in the future. And again, these callbacks also are going to happen, these cleanups are going to happen in the same order as the useEffect defining them. So cleanup 1 happens before cleanup 2, and so forth. So let's talk a little bit more about this. So after our component returns a value, and that value gets rendered in the DOM for the first time, aka component did mount, that's when we call the argument that we passed it in the first place, the effect. So on a subsequent re-render, aka the did update, which is the situation we just described, first the cleanup that was returned earlier gets called. Then the new callback gets called, which means that the cleanup that it just returned is now waiting in the wings for the next re-render again. So right before our component is removed from the DOM, aka component will unmount, is when only the cleanup gets called. So the cleanup can be called a bunch of times, and the callback can be called a bunch of times, but the cleanup is going to be called only at the end, and only the callback is called at the beginning. Does that make sense? Yeah, kind of, sort of? Okay. We'll see an example in just a minute. I think that might help a little bit. So if you think about the structure that we had here just a moment ago, let me go back. This means that on every subsequent re-render, we're going to subscribe and then unsubscribe on every subsequent re-render. It seems pretty uncontrolled, right? Like, what is the use of this effect really if it's, okay, great, it's component did mount and will update and like will unmount all rolled into one, but it means that I'm using my effects like a crazy person, and this is going to be just a bizarre series of requests from my APIs and whatever else I'm using it for. So this is where the comparison array comes in, which is that second argument that I talked about a few minutes ago. The comparison array is how you gate the firing of these effects, okay? So the useEffect is an amalgam of did update, did mount, and will unmount. But you can control when it fires so that it behaves only like a did mount and will unmount. And you can gate it with this comparison array. So what the comparison array is it's purely an array that you stick values in. And if you pass an array, useEffect is going to monitor for changes in that array on every time that it gets called. And if the value is changed anywhere in that array, it's going to call the effect again. And if it hasn't changed, then it won't call again. So an example here would be, okay, let's render this component with a username, and we're going to have a counter. So on the first run through, we have the count set to 0. Our useEffect is a callback with the subscribe and unsubscribe that we've talked about. We pass it an array that contains only the user's name, and we have the count button. All right, so we return the count button, and now our useEffect callback gets called. We subscribe to the API with this name, and we return a callback that isn't going to be called yet, the cleanup. So now we click the button again. Name stays the same, right? But the count goes up by 1. So now the re-render begins again. So we wind through, we get to name, and hey, the name hasn't changed. So I'm going to return the count, the new updated count, but because the name hasn't changed, I'm not going to call useEffect again. So I am not going to unsubscribe, and I'm not going to resubscribe. I'm just going to stay as is. Effectively, what I did was I created a component didMount hook now, right? So let's say the user clicks a button a few more times, and then the component above it gets unmounted, or whatever condition that was making this component render goes away. So now this component unmounts. Now, component will unmount, that portion of the lifecycle fires, and regardless of whether this array has changed, the cleanup gets called. So the cleanup is going to get called, effectively unsubscribing you from the API. So this is how you're able to have the initial effect and any subsequent cleanup that needs to be done all rolled into one place. And so let's put these into hard, concrete rules. If you don't pass in an array at all, the callback and the cleanup are going to run on every render. Really noisy, but sometimes that's what you want. If you return a static or an empty array, then that's when it's going to do the callback on the mount and the cleanup on the unmount, effectively making it such that your useEffect is a component didMount and a will unmount, right? And do note, this is super important and goes back to me mentioning before that the function changes on every subsequent call. The props and state values in the effect will always have their initial values in this situation of a static or empty array. So to go back for a moment, talking about this example where we had the name, right? So let's say it starts off as Joe, and that's what this component first renders with. So we've returned a callback where we're saying some API.unsubscribe Joe. Well, the user clicks a button a few times. Now some situation up above changes, and the name prop changes to Brenda. Well, this is going to become a problem if our useEffect is taking the scope of name with every call, right? Because now our callback is going to be some API.unsubscribe Brenda, but we never subscribed to it in the first place. So like, what does it mean to have some API trying to unsubscribe based on a new name? And this is where it becomes essentially important that we are returning a new function on every re-render. Because 50 clicks ago, when Joe was the one that signed up, we saved this some API.unsubscribe. So now that we've saved some API.unsubscribe Joe, on some future moment when Brenda gets passed in, thus changing the name, thus indicating that the cleanup from before should now be called, well now we can say some API.unsubscribe Joe because we have been holding on to this unsubscribe Joe the whole time. Does that make sense? Yeah? Cool. So that's if you have a static or empty array, and then if it's an array of changing values, which is the situation I just described, then the callback is going to be on mount, and the cleanup will be on unmount, and then any additional calls will occur to this cycle anytime a value in that array changes. And as I note here, props and state values in the effect have the values that were passed when the array last changed. So this is how we keep this cleanup clean. Okay, so now let's move on to, and let me check the time. Okay, yeah, I'm going to move a little quickly here at the end. So the last two things that we're going to talk about are use query and use mutation. As they sound like, they are Apollo provided hooks that let you use a query or use a mutation. And they're very elegant in their simplicity. So the Apollo use query fetches a GraphQL query and then provides the result. As the request status changes, re-renders are triggered. So you just need to render based on the status of the request. So you create a query, using this GQL syntax that we looked at earlier. Then you have a component that calls useQuery, and you pass it the query, and it returns an object with data, loading, and error. And when loading is true, the query is loading. And the moment that it changes from loading to either error or returning data, it's going to, because you called it within the component, it's hooked into the component's lifecycle and updates, it tells that component that it needs to re-render. So now it's going to try to re-render, and if it's an error that it's re-rendering with, then okay, let's do an error message. And if it's data that we're returning now, then we can safely assume that it's the data that we wanted to get from our query. So it's super elegant and really simple to write stuff that would otherwise require like a bunch of Redux to basically track the state of things changing over time. It makes our lives surprisingly easy. Yeah.
Use query, I guess it returns an object and it keeps a reference to that object. That's why you can go in and update.
Yeah, so it's hooking into a memory cell, right? So just like useState is assigning some value to the memory cell for that first hook call. And React's engine is under the hood listening for changes to that value and then determining that a re-render needs to happen when that value changes. Similarly, useQuery under the hood is putting information into this memory cell, and then React's engine is tracking and monitoring it. And so when useQuery then pushes off a change in that value to it, the React engine is responsible for saying, there was a change, I will re-render.
Use queries, I think it's just a function, right? A custom.
It is.
So
It's
it's not really hooked into React.
It is though. It is because you can write your own hooks.
Right, but when you write your own hooks, it's still just a function.
It is just a function, but it's a function that relies upon the context of being called within a component. So the assumption that it makes is that it has access to this underlying React Engine API that it's able to talk with and manipulate data through. And so under the hood, they've written a function that assumes access to this engine that is listening for these exact types of changes. So you're right that it is just a function, but like so is useState and so is useEffect, right? Like they're all just functions, but what makes them hooks is that they all assume the context of the React engine that they're able to hook into and communicate with, right? So the people at Apollo spent a bunch of time to basically effectively hook into the engine, and I don't know what under the hood they're using, but I'm assuming it's very conceptually similar to useState.
They actually do use state.
There you go.
Use state and use effect.
Oh, okay.
How they hook into it, which causes the re-render.
There you go.
Yeah.
Cool. Thank you.
Yeah.
So the other argument that you're able to pass that you're going to see us use is an options argument. And that options argument is going to receive a few different values that we'll be passing. One is going to be variables, which are the variables for the query. So, when you're submitting like a get user by ID, the variable would be ID, and that key name of ID is going to correspond to the arguments that the query expects. And then fetch policy is going to be how you dictate whether you want your request to come from the network or from a cache that Apollo is managing locally. So like I mentioned before, Apollo is really chatty, so it leans pretty heavily on caching. So what you're able to do is, and we didn't even talk about caching because that's a whole other can of worms, but you're able to basically dictate whether you want each of these requests to be always a new request to the network, so you guarantee that the data is up to date, or that it's cached and you're okay with it. So it defaults to using the cache for every X seconds, and then after X seconds, it's going to make a new request. But sometimes we want network only. And the other thing that we do is on completed, and that is where you're basically able to say, after the data has been completed and returned, do this thing. And you'll see why you want to do that sometimes instead of just using the data value that's returned up here. So let's move forward. So use mutation, conceptually similar. It is a hook that allows you to submit mutations, as it sounds like. And just like the use query, as the request status changes, then re-renders are triggered. So you just render the component based on the status, just like with use query. One thing to note is that where use query calls the moment that you call it, right? Like it immediately makes a query. Use mutation is not going to execute the moment that you call it. What it returns is an array where the first value is a function to submit that mutation. And the second thing that it returns is an object with the data, the loading, and the error. So in this contrived example, we would have a handle mutation function that receives a value. And what we would then submit is, we would say submit mutation, which is the thing that was returned by use mutation. And we would pass it this variables object, just like we did with use query, and the values that we want to have set as our variables. Does that make sense? Yeah? Okay. I know, we're getting to the glazed over point. It's been a long, 2 hours of me shouting at you. Just like before with use query, use mutation is also going to receive a second object. And in this case, we're going to have on completed, and we're also going to have on error. I left on error in because I ran into, as I was developing, I kept getting malformed requests because I was in the process of writing things. So I just threw this in there to help catch malformed requests, and so you can console log in there to see when you're messing things up and stuff like that. Okay. So I'll say, what we've left out that we haven't talked about yet are schema helpers, which include things like inputs, fragments, interfaces, and unions, which are all in the docs. Schema version management through that Apollo tool. GraphQL best practices we touched on but didn't go into too much depth on, as well as additional examples. So all of that stuff is going to be rolled up into the documentation. And two things I didn't talk about in the docs at all because they were huge cans of worms, were subscriptions and caching through GraphQL and Apollo. So what we're going to do now is we're going to move on to that final speedy phase where we crank out a UI in 10 minutes. So buckle up, Buttercup. All right, get both hands here. So the first thing I'm going to do is open the UI, and I'll show you the top-level index.js real quick. So if you haven't used Material UI, you should. It's awesome. It takes a lot of work out of doing a lot of different things and makes very pretty components very quickly. So this is me setting up a theme for Material UI. There is a cache that I'm setting up for Apollo. There is basically a link, which is AKA the gateway. So this is us telling Apollo, this is the gateway that you're going to talk to. This is me setting up middleware to add the authorization header, which our gateway expects, right? So our gateway is saying anytime you have an authorization header that is a JWT token, try to decode that token and then set that user ID across the requests that are being sent out. So we have that JWT when a user logs in, we store it in our browser's local cache. So I'm saying that on every request, I want to try to get that user token out of cache and send it on along with everything else. So this is just a middleware, so anytime I try to submit a query or a mutation, this authorization header is gonna get shoved onto it, is all this means. This is another middleware called an error middleware. And basically it's listening for on error, do a thing. And I'm saying that when there is an error, if that error is that the user is unauthenticated, AKA they sent a bad JWT, they sent a bad token, then I'm gonna remove that user's token from their local storage. So this is a way for me to say, oh, you opened your browser, you were logged in for 8 days, but you kept your computer in standby or whatever, and then you reopen your computer and you just start trying to use the page again and your login has expired. You're gonna submit that first request, and when you get back unauthenticated, it's gonna auto log you out. So Apollo relies, all of this stuff happening relies upon this Apollo provider component. You can read all about this stuff in their documentation. I don't go super into it because they kind of just lay it out very plainly, and I felt like I was kind of just copying and pasting docs at that point. So yeah, this is just the basic boilerplate for getting Apollo set up in your browser. The other thing I will show you real quick is the app component. And we may go several minutes over if that's okay with everyone, I'm sorry. This is the first situation where you're gonna see use state, and this is simple routing. If you have seen routing before, this is probably pretty familiar to you. And all we're doing here is we're saying that on every render, the user being logged in is going to be set to, on the first render, we are going to try to get the user out of our local storage. And if that user is valid, then we're going to say that logged in is true. And when login is true, then that's like how we dictate whether we want to redirect to the profile page when they go to the login page, or if we want to redirect to the home page versus the profile page when they go to the profile page. So basically logged in is going to become this stateful value at the top level of our component, and we're going to have a login function that we control access to and like setting this variable, right? So we have login as a variable or as a function, and we're gonna say that it will simultaneously save the user token in our cache and at the same time is gonna set the local state of this component to logged in true, right? And then logged out is going to remove the user. And under the hood, if you look at it, because this is like demo code, I just do a little hacky thing where I just force the redirect to the home page, which like refreshes the page, which clears out the state. So there's no need to set logged in false because like everything just refreshes anyways. Okay, so that's like the top level. So let me show you the home page. All right, it's beautiful. Git checkout 5 UI homepage. Dun, 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 dun. Simple. What we want to see is a homepage where we use a query of get recent favorites, data loading an error. If loading, return a spinner. If error, return an error message. And then we, assuming now that we have data, that data is going to be recent favorites, which is an array of songs where each song has an ID, an artist, a created at, a reason, a name, a user. And so we can now safely assume that that is what our data looks like, right? ID, artist, created at, reason, name, user. And we then pass each of these things over to our listing object, which has its own stuff going on. And I'll show you that in just a moment. But for now, we can actually look at the workshop. And I need to turn on the UI. Okay. Heave ho. Luckily, it doesn't take too long. Well, that goes, I will talk about the listing component. So the listing component has two things going on. One is that it allows you to update a favorite if it's yours, and the other is that it allows you to remove that favorite if it's yours. So as we just established, it receives artist, a created at, a reason, a name, a user, the ID of that song. And so we've got a few things going on in here, but what it is mostly is use state, which is the reason that you're able to set locally. So this would be if you're updating an existing listing to contain like, oh, this is no longer my favorite because of its lyrics, it's now because of its sound, right? Then the use mutation is how you submit that update. The submit favorite remove is a way to remove that favorite by clicking a trash can. And when it completes, we remove that favorite from our local state instead of refetching the data, right? So when we first successfully fetch everything, we're saving that information, and then we're removing it with this, yes. So here's the handle reason change, handling delete, right? So these are in turn calling the things returned by the use mutation. And then here's all the conditional stuff that goes into making that happen. If you can edit, AKA it's yours, show a delete icon. And when you click it, delete it. And whenever you can edit, let's show a drop down where you're able to change what you liked about it. And the value is going to be these hard-coded values that are part of our enum, right? Or yeah, our enumerable, right? The everything, the lyrics, or the sound. And if it's not editable, AKA it is not yours, then it's just a simple card where we say, who is it favorited by? When was it favorited? They love it because of everything or because of the sound or the lyrics. So let's see what this looks like in practice. All right, let me log out. That sounds right. Oh, I bet you the gateway's not turned on. It is not. So hey, our error handling worked. That's exciting. Okay, so now the gateway is working, stitching all the things together. Yay. So now we have a listing, and when we click the top of it, it's going to only show the song, which is our placeholder right now, right? And when we click the bottom, it's going to show the user page, which is currently a placeholder. And if we try to log in or sign up, all just placeholders. So we've got progress. Hooray, it's not broken forever. Let me now go to update the user component so that we can actually see something about this user. Git checkout 5 UI user. All right. So here's our query, right? And if you notice, I literally just copied what I took from the GraphQL interface over here. Like literally just copied it, pasted it, good to go. And that's why this is so great, is like you can play with it in this playground, you can request exactly the data you want, and now that you've verified that it's working with tooling that tells you, oh, hey, this field is invalid and doesn't exist, you get all of this like immediate validation of what is and isn't working, and then copy that bad boy into your code and use it immediately in this like very simple way of like, is it loading? Okay, spinner. Is it broken? Error message. I've got a little bit more complex handling here, right? Because sometimes you can receive data back, but it's not succeeded, right? Because like, let's say the user doesn't exist, so you'd get like a no user error. So if success is not true, looks like that user doesn't exist. Otherwise, the user definitely exists. So now let's get that email and favorite information out and show their favorites. So with this built, if we click this user, dun, 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 we can now see their favorite songs, which is pretty sweet. So now what we can do is git checkout 5 UI song. Okay, so the next thing I want to mention is that this component like also has this success and message handling just like before. So where before I knew that if I didn't have a success that it was because the user didn't exist, now there's like 2 potential reasons that we could have a non-success, right? One is, there's no song. The other could just be like something else has gone awry and I don't really know what it is yet. So I'm giving a specific error for, that song doesn't exist, and then a generic error message in all other situations. I'm then assuming safely that the artist name, lyrics, reason, and user exist, and I'm showing that information about that song. So with that in place now, theoretically, if I click this, it's going to load for a second, then show me the information about the song. And if I try to go to a song that doesn't exist, that song doesn't exist. So the last pieces here are going to be the sign up form. Okay. So this is the basic form where we want to be able to submit a mutation for signing up. So here's the use mutation where you submit a sign up and you get back the data, the loading, and the error. And because there's now a lot of scenarios to handle, I'm going to set this error message conditionally, right? So if there is data and that data includes the sign up key, then I can safely assume that there is a data.signup.message. Maybe it's null, but maybe it's incomplete data, in which case I want my error message to say that the email and password is required. Maybe it's that it already exists, so okay, that user already exists. And maybe it's that something else went wrong. So this is like a very basic form. So if I go to the sign up form, I now have this very basic query. And if I do this and try to sign up, email and password are required. If I do test@email.com with a password of test, that user already exists, right? So it makes it really easy to like just quickly build some stuff out. The next thing I will briefly talk about, well, actually, I'll skip it. It's in the documentation. I'll just go through the remainder of this because there's like 5 more steps to get through. And I would like to not keep y'all here till midnight. Oops, complete. There we go. Okay, so what I added here was simply the on completed and on error handling. So what I'm saying is that when this mutation completes successfully, if it succeeded, then I want to log in with the token that I just got back, AKA I want to call this callback that was given to me by the top level app component, where I save the token to my cache and then set logged into true for the overall state of my application. And you can easily see how this could become like a context through like the context API, or it could even like use Redux if you wanted. And the reason that I do it here instead of like down here is because if you think about like on every subsequent re-render, data.success is still true, right? So like if I just said if data.success log in, I'd be logging in on every re-render, which is arguably not a good thing. Okay, so that was that. Git checkout 5 UI login. Okay, we're nearing the end. Login. Okay, so this is basically the exact same component, right? Instead of signing up, I'm logging in. But other than that, they like are nearly identical, right? The only difference is that there's like one more error type to handle. So now let me go to that login page, and if I try logging in, email and password are required. Okay, that user doesn't exist. Test@email.com, invalid password. Yay! Yeah. We're getting there. Okay, so the next thing I'm going to show y'all is the profile page, and that's the last page. Git checkout 5 UI profile basic. Let me close this and this and this. Okay, so the basic profile page, here's that fetch policy of network only that I mentioned before. And I'm setting it to network only here because I'm going to be making mutations to data. And I would like to really guarantee that every time I'm looking at this page, it's definitely the most up-to-date data. Maybe overkill, but I did it, so. I get the ID and the email for the user out of my system local cache. And then I say that the favorites on this profile page are starting out as an empty array. Then I'm going to use a query to get those users, to get that user's information, which is going to include all of their favorites. And on complete, I'm going to set the favorites locally to user.favorites. So what I'm going to eventually get is a set of other functions that will operate on this array locally to remove them and add them as I make changes instead of going back and refetching more information. So maybe that's like a bit of a naive implementation, but again, this is like demo code, so do with it what you will. So here we are. Here's our profile. We can submit changes, and it worked. It's just really fast. And if you refresh the page, like that is the persistent actual value. You can choose to delete it if you want. I don't want to because it is my favorite. So yeah, that's pretty much what we've got going on here so far for the profile page. So now if we git checkout 5 UI profile, all the things, remove song. So this is relatively straightforward. All I'm adding is this remove favorite function. So I'm going to get the index of the song ID, and I'm going to update the favorites to remove that song and set the favorites locally to that updated value. And I'm calling it on complete after, and you'll see in a second, like this is me basically preparing for that functionality. So let me, oh, actually, no, I'm sorry. So the listing, as I showed you before, contains update and remove favorite. So whenever I pass remove favorite here as a prop to the listing, and I submit those changes, and the listing is removing submitting the actual mutation, upon completion, it's using its own props to call remove favorite, right? So down here, whoa, remove favorite. So yeah, when submit remove favorite mutation completes, call the prop remove favorite. Yeah, and pass it the song ID. So it goes up a level back to this profile, which is managing its own state, and it removes it from its state. So let's watch it. Oh no, goodbye. So if we go back to the workshop page, it's now empty because there's no songs. So now the final 2 steps, we're getting there, it's happening. Add song start. So I added a few local states here. State for artist, name, reason, and favorites. Or excuse me, just artist name and reason, right? We already had favorites. So this is now the state values for supporting adding a favorite, as well as handling functions for each of those state values, where I get the target value from the field and then set it locally. So if we look at my profile, I now have an add a new favorite. So we could go with Hey Jude and the Beatles, and let's just go with the lyrics. And clicking it does nothing for right now. So it goes. So the last thing I'm going to do is actually add that true functionality. So git checkout 5 UI profile add song complete. Okay. So the last thing I did here was I added the query, or excuse me, the mutation add favorite, and I down here called use mutation to use that add favorite, and said on complete, if it was successful, add the favorite to my local state. So I know that I've successfully submitted it to the GraphQL database, so now let me add it locally as well. And I get that song directly out of the response, right? So I know for sure that what I'm adding to my state is a real value from the database. So let me do this and that and lyrics. Yay, there you go. And you can change it to be whatever you want. And if you go back to the workshop, it'll be there. So that is everything. I know that took a while. I hope it made some sense. Thank you very much. And here's some resources if you guys want. And yeah, thank y'all. Yeah, for sure.